All right, last but not least, our bread and butter, the paired t-test. In this case, every row is the same participant, and we're looking at repeated measures. So they took a pre-test and a post-test, which is our most common example. Our null and alternative hypothesis. Most of the time, we're curious. We want to know if their post-tests were significantly greater than their pre-test, signifying some amount of learning or some amount of change. But this could also just be if it's significantly different, just like we did before. If that's the case, then we're just looking at not equal to 0. But in this case, since it is a pretest, we are hoping that their post-test is significantly higher than their pretest. Thus, we have the null and alternative hypothesis laid out this way. That also means when we go to interpret our results, we're going to be looking at a one-tailed test. So let's go to SPSS. Here we have the pretest and post-test data. Again, this is simulated. There's no real meaning to it other than the post-test should come out significantly higher. There's no special coding or anything we need to do either, like in the independent samples t-test, because every row is the same participant. So this is one person's pretest, one person's post-test. To run the test, again, analyze, compare means, this time paired sample t-test. Now, this window looks a bit different than the other ones that we've worked with so far. You'll see that here you have pair, variable 1, variable 2. You can put pretest and post-test in either of these options, but that's going to change the sign of the results. So to make it easier, what we're expecting to be on that outcome, i.e. our post-test, our later measure, we're going to put that one here first. And then in variable 2, pretest, we'll put that in variable 2. Effect size, and just leave the radio buttons down here. And again, options bootstrap don't need to do anything with. I'll point out once this runs why this order matters. You can do it either way, but it just makes it easier to interpret if we do it this way. All right, as before, we have our descriptive statistics up here for this pair. Our post-test mean was 78, pre-test 73. So just looking at the pure difference in the means, yes, it does look like on average people increased their score. Standard deviations, they narrowed, which is good. It's not a lot, but you can see where they've come together a little bit. And our standard error. When we do a paired samples t-test, it will present you with correlations as well. So this is the correlation between our pretest and our post-test. And as expected, they should be very high, 0.98. That's almost a perfect correlation. And then the significance to the correlation. If that was very low, there would definitely be something off, given that for most cases the same person took, or they should have taken, the pretest and the post-test. So they should be very similar. Then we get to the results. Again, this one looks a little bit different. We don't have the Levine's test over here. We have post-test minus pre-test, which is what helps us see that mean difference. So if we took our post-test and we minused our pre-test, we know that post-test is higher. We're going to end up with a positive number. That's our 4.8. Our difference, our mean difference. We got our standard deviation, standard error, confidence interval. And here on this one, the t-test is farther to the right than the other ones. Before, we always had the t-test right at the front. Here our t-statistics is 22.56. Degrees of freedom is 19 and minus 1. And then since we presented the question of greater than, we're going to be looking at our one-side test. Both of them are less than 0.001, meaning that the post-test was significantly greater than the pre-test. Again, effect size is down here, and that's it. Now I will show you, just because it can be confusing, if we were to enter these in a different order and see how this changes. So we know that post-test, pre-test, 4.8 significance value, and t-statistics. I'm going to run it again. I'm going to go back here. Analyze, compare means, paired sample t-test. This time, I'm going to take these out. I'm going to put pre-test in there first. So before we had post-test as variable 1. Now we have pre-test as variable 1. I'm going to run it again. And now we can see here, since it's pre-test minus post-test, now it's a negative 0.48. and a negative t-statistic. We still have the same amount of significance on both sides, but the sign has changed because we've switched these around. So since we're doing pretest minus post-test, it's negative, which is saying that pretest is significantly lower than the post-test. So just keep in mind that you pay attention to which variable you're putting in before you interpret the mean difference, the t-statistics, and the significance, because the order of the variable will change your results. And that's it. That's a paired sample t-test.